All right, so 11.1 and 11.2. So this first one. So we're talking about binomial expansion. What does binomial mean? What does bi mean? Two. Okay, so we're talking about two terms. Okay. So two terms to the first power. So if I go a plus b to the first power, my answer is, you guys are so intelligent. Okay, when I have a plus b squared, this is where you would use your box method to multiply this out. Okay, so let's go ahead and make a box. Okay, however you want it, or if you foil also works. Okay, so we have a and b and a and b. My box is kind of small there. A times a is a squared. A times b is ab. B times a is, we're going to write that as ab, though still in alphabetical order. And then b times b is, so if you notice, these are like terms here. And we end up with a squared plus 2ab, because there's 1ab and another 1ab, which is 2ab, and then plus b squared. So if you notice, there are three terms here, so we're going to write those in the blank. And we have a squared plus 2ab plus b squared. Okay, we're going to end up seeing a lot of patterns here, so in this lesson, it's super important that you guys kind of pay attention, and we're going to talk about everything that's happening because it's going to help you with the rest of this, okay? All right, so a plus b to the third power. Remember, when you have a third power, you have to multiply two of them together first, and then we end up multiplying the third one. Well, I've already multiplied two of them together, right? So now we're going to make a box, but this time it's going to be a 3 by 2, and we're going to multiply out again. Yes, good. Okay, so we have here, on the top would be your a squared, 2ab, and b squared, and then on the side I have a and b, right? So when we multiply in this first box, a times a squared is? Good. A cubed, or a to the third power. A times 2ab would be? Good job. A times b squared would just be? Good. B times a squared? Good. A squared b. Always still keep them in alphabetical order. B times 2ab would be? 2ab squared. Good job. And then b times b squared is? B cubed, or b to the third power. Okay, and again, in our diagonals, we can see our like terms here. So I still have a to the third power. And then I have 2 plus 1, right? 2a squared b and a squared b. So 2 and 1 would make? 3. So 3a squared b. And then we have the next one's going to be?
3ab squared.
Good. 3ab squared plus b cubed. Okay, so we're going to write that on this line. So again, there's 4 answers here, 4 lines here. So we have a to the third plus 3a squared b plus 3ab squared plus b cubed. Okay. We are going to start talking about some patterns right now. Are you guys ready?
No.
Well, so what would I need to do in order to find a plus b to the fourth?
Just multiply 4 by 2.
Right, so we'd have a 4 by 2 because we do this one that we already multiplied for the third and multiply it by another a plus b. And then each time it's going to end up being a longer and longer problem, right? Which is, we could do it, but it's just a little bit annoying, right? We'd rather take the shortcut. At least me. Would you guys rather take a shortcut? Okay, so let's start looking at patterns. Okay, what do you notice? Like, how many terms does this have?
2.
How many does this have?
3.
This has
4.
4, and without counting, this one would have?
5.
So, if you have this exponent, that means when you multiply it out, you're always going to have
5.
one more. So if I said like a plus b to the 20th power, how many terms would end up being in your answer? 21. Okay, do we all agree with all that? Okay. Do we see any other patterns?
Yeah, A's and B's.
The 2 increases the exponent.
Okay, so if you look here, I don't know if you guys noticed this, but see here this exponent, you have a squared, and then this goes a to the first, right? We just don't normally write ones. And then this is a to the, this is a to the 0 because there's no a's. So this went 2, 1, 0 with exponents. Look at the b's. 2, 1, 0. Look here. 3.
2, 1, 0. 3, 2,
So that means it's going to be 4, 3,
So
2,
it's-
1.
Okay, so do we see all that with the exponents? Also, there's another thing with the exponents, if you look. See how this is a square?
Yeah.
This is a square. What,
That's what I
add your exponents together. How many, what, and if you were to, this is a first and a first, right? So 1 plus 1 makes 2. This one has 2. This has, we're in the third column now, right? See how this exponent has a total of 3. 2 plus 1 makes 3. 1 plus 2 makes 3. This is 3. So that means that here, all of my exponents with each specific term, the exponents need to end up adding to be 4 when we're in the fourth power, right? If we're in the fifth power, the exponents would need to add to be 5, and so on and so forth. Okay, there's one more pattern we want to look at. So if you look at the numbers that are in front, okay, this number in front of here is actually a 1, and this number in front of the b is actually a 1. Okay, and then in front of this a squared, it's a 1, and then we have 2, and then this one is a 1. This one, this is a 1, 3, 3, and then a 1. Do we notice a pattern there?
It's always 1 on the outsides and the number stays the same.
Good. So on the outsides, there's always ones. Okay. Now this is where Pascal's triangle comes into place. Okay. Right here, this is like your first power. This is where you get your front terms. So see how this is 1 and 1 here?
Yeah.
This is where 1 and 1 came here. Okay. This one, do you see how it goes 1, 2, 1?
Yep.
On this one, it's 1, 2, 1. The next one, do you see how it's 1, 3, 3, 1? And here it's 1, 3, 3, 1. So what are going to be my numbers in front on my fourth power?
4, 6, 1, 4, 6, 4, 1.
Okay. And then, okay, and then what would my exponents be? What am I going to start here in terms of my A? A is going to be to what?
4.
The fourth. And then A is going to be to the third. And then A to the
2.
second. A to the, and then do I need to write A to the 0? No. Okay, then I normally just go backwards. So this one is going to be B to the fourth, and then B to the third, and then B to the second, B to the first, and then B to the 0. And again, double check your exponents. This one adds to be 4. 3 and 1 makes 4. 2 and 2 makes 4. 1 and 3 makes 4 and 4. So I can double check myself with my exponents to make sure they add to be the fourth exponent. Okay, moving on to Pascal's triangle for 1 minute before we go and fill out this one. When you're making Pascal's triangle, you always have 1s on the outsides. So you start with 1. This is like anything to the 0 power equals 1. This is your 0 row. Okay? Then we have our 1s on the outside. Now if you look here, 1 plus 1 adds to be what? 2. Okay? We have 1s on the outsides. If you go right here, 1 plus 2 equals
3.
3. 2 plus 1 equals 3, and then you get a 1. We have a 1 again. Look here. 1 plus 3 equals 4. 3 plus 3 equals 6. Okay? And then 3 plus 1 equals 4, and then you have your 1 on the outside. Same thing. Keep going down. You know, you have 1. You have 1 plus 4 makes 5. 4 plus 6 is 10, and so on and so forth. So you are going to end up making your own Pascal's triangle. And so even to start with, you know, we can all put our 1s down all the sides, right? And we're not going to go through and do all this right this minute. You guys can end up doing this later. But so you get all your 1s in there, and then again, we know here, 1 plus 1 makes 2. For this box right here, it's connected to these two. 1 plus 2 makes 3. Here, 2 plus 1 makes 3. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And you can go, and so on and so forth. And obviously it'll continue to get larger as you keep going down. Okay, pretty cool, huh?
Wait.
I mean, mathematically speaking, yeah.
Wait, so that's what we have to do right now?
No, I just am letting, because if it were me, I'd want to keep doing this. And yep, so 5, 5, 10, 10, 5, and then we'll have 6, 15, 20, 15, 6.
2, 3, 4,
All right. I know, I figured some of you would want to keep doing this.
5, 6.
But if you can stop for a minute, or actually, as you're making this, do you guys notice any more patterns?
Yeah, they're all the ones and then it goes adding.
Yeah, so this side all goes 7, 8, 9, 10, 11, 12.
And that one you add 2, then add 3, then add 4, then add 5, then add 6, then add 7.
It's pretty cool how many like patterns are in this.
3 add 6.
And also, like this first number right here is telling you your power. So this 2 represents when I have something for the second power. This 3 represents it's going to be something to the third power. You know, this one would represent that I have a plus b to the 6th power, and so on.
Wait, so could you do the next row real quick? And just
Okay, what is 6 plus 15?
21.
21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21, and 6 plus 1 is 7. Okay, I'm going to take this away, and we're going to come back here. So, could you guys do your 5th exponent and your 6th exponent? So the first thing you always want to do is start with your coefficients. Remember that coefficients are the number in front of your letters. So if I go to my 5th row, okay, which is right here, or if you have your Pascal's triangle right next to you, you can go to the one that has 5 as the exponent. And what are my numbers that are going to go in front of each of these?
1, 5, 10, 5, and 1.
Good, thank you. 1, 5, 10, 10, 5, 1. Okay? A is going to be to what exponent here? A to the 5th, A to the 4th, A to the 3rd, A to the 2nd, A to the 1st, A to the 0, which I don't write. And then B to the 5th, B to the 4th, B to the 3rd, B to the 2nd, B to the 1st, and B to the 0, which I don't write. Okay, I'm going to give you about 20 to 30 seconds. You do the 6th one on your own, and then we'll double check that you did it right.
And then it's going to be.
How do you know
What number?
So when you have your 6th exponent, you want to go to the row that has a 1 and then a 6. So that 6 is telling you it's your 6th power. Yeah, if you guys have questions, you can ask me while you're doing it. Okay, so what were the numbers that you put in the front? What were your coefficients?
1, 6, 15, 20, 15, 6, and 1.
Perfect. All right, and then we'd start with A to the 6. Yeah, I'm like, it's not a trick question. And then A to the 5th, A to the 4th, A to the 3rd, A to the 2nd, A to the 1st, A to the 0. And then we have B to the 6th, B to the 5th, B to the 4th, B to the 3rd, B to the 2nd, B to the 1st, B to the 0. Okay, does everybody feel pretty good about this? Do we have questions before we move on? Okay, because this next part is where we're kind of doing more of our problems. This is kind of understanding why it works the way it works and how we do the problems. Okay, so on example 1, let's see if you guys remember. If I have x plus 3 to the 5th power, how many terms am I going to end up having? 6. So what you should do so that you don't mess up is make your 6 blanks. So I'm going to make 1, 2, 3, 4, 5, 6. Okay, and I'm going to put my plus sign in between.
But the exponent is 5.
Right, so remember how we went back, if you go back to the top, if you had a 1 as an exponent, you had 2 terms. If you had a 2 as an exponent, you had 3 terms. If you had a 3 as an exponent, you had 4 terms. So the number of terms is always 1 more than your exponent.
Oh, yeah, that's right.
Okay?
That makes sense now.
Good. Okay, so what are my coefficients that go in front of each of these blanks?
1, 5, 10, 10, 5, and 1.
Good. 1, 5, 10, 10, 5, 1. Now, this time my A term is x. Excuse me. So I'm going to write that here. We're going to start, and I'm going to go x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and then we have our x to the 0. Now the reason why I put some of these in parentheses this time, and you don't have to with the x, is that sometimes we're going to have a number that we're raising to an exponent. Or maybe your first term is 2a. So you're taking 2a to the 5th power. So that means you have to take the 2 to the 5th and the x to the 5th. Does that kind of make sense? So whatever this first part is that's in front of the plus, you're taking it to that exponent. So if there's 2 things there, you need to make sure you're taking both of them to that exponent. So now when I have the 3 and I'm starting backwards, because my b term is this 3, right? So that means starting back here, this is going to be 3 to the 5th power, and then I have 3 to the 4th, and 3 to the 3rd, 3 to the 2nd, 3 to the 1st, and then 3 to the 0.
So is that just 1?
So now, and what I normally do is like, see how I have 2 numbers here on this one? So I'm gonna, the first term is good, you know, I just have x to the 5th. But on this one, I have 5 and 3. So sometimes I'll write like this, 5 times 3, and I get, hold on, 15x to the 4th. Okay, so I'll kind of take a couple steps here. On this one, I'm going to have 10. I'm just kind of looking at my numbers right now. What is 3 to the 2nd power? 9. So I'm going to end up with 10 times 9, which is 90. And then I have my x to the 3rd. Plus, on here, 3 to the 3rd power is, so I'm going to end up with 10 times 27, which is 270 x to the 2nd. Here I have 5 times, and what's 3 to the 4th? Good, so 5 times 81 is 405, and then that's x.
Oh, 90.
And then 3 to the 5th is 243, very good. And 243 times 1 is just 243. So this ends up being my final answer.
And then what? 40.
So when you have numbers, you just have to be careful because you have to,
So we have to solve it too?
that's it, you've solved it. You've expanded it. The whole thing is you're expanding
Oh, we
these.
have to do the x.
Is that 200? I mean,
You have to do everything that's here.
We have to do x to the 5th plus 10 to the x.
40.
Like, they're
Yeah.
easy, but they take.
But imagine if you had to multiply out 2 and then 3 and then 4 and then 5. It would take you a really long time.
Oh my gosh.
Okay,
Does that mean Minecraft?
5 seconds. 1 second.
okay.
Where? Yeah, but this is L.
I didn't get
Okay. All right, so moving on to example 2.
All right.
How many blanks am I going to need for this one?
5.
5. Always one more than my exponent. So we have 5 blanks. Okay. 1, 2, 3, 4, 5. Okay, for my fourth exponent, what are the numbers that go in front? Thank you. 1, 4, 6, 4, 1. Okay? With my A's, it's just A. So I have A to the fourth, A to the third, A to the second, A to the first, A to the 0. But for my second term, Austin, I have 2B. So we have to be careful with that one. Make sure you put it in parentheses. So this is 2B to the fourth. And then we have 2B to the third. And then I have 2B to the second. 2B to the first. And then 2B to the 0. So on this one, I'm going to end up with, so I still, A to the fourth is good, right? On this one, 2B to the first is just 2B, right? So that means I just have a 2, and so we have a 4 times 2, and I end up with A to the third B. Okay, plus. Okay, so this one I have a 6, and then I have 2 to the second power. What is 2 to the second power? 4. So in terms of my numbers, I have 6 times 4, which is 24, and then I have A to the second and B to the second. Because that second power went to the 2 and the B, right? Okay. Very good. So on this next one, we have 4 times, and 2 to the third power is 8. So 4 times 8 is 32. And then I have A and B to the third. Because remember that 3 goes to both the 2 and the 3.
So it's 16 before.
Good. And then this last one, 2 to the fourth power is 16. And then you still have your B to the fourth power. So that is 16B to the fourth. And that's your answer. Okay. What, do you guys notice something a little bit different about example 3? It has a subtraction sign. So if you think about it,
And there's a number in front of the first letter.
right, and we've kind of dealt with the number in front, so we kind of know how to deal with that, but we haven't dealt with negatives. What happens when you raise negatives to exponents? Sometimes it turns to a positive, and sometimes it turns to a negative.
It's only a negative when it's an odd number, right?
Yes, so it's a negative when it's an odd numbered exponent, and it's a positive when it's an even numbered exponent.
It's going to change to a positive.
So it's going to go back and forth here between negative, positive, right?
Oh, yeah.
So it's going to be minus, plus, but there's going to be, that's another pattern. It's going to be minus and then plus, and minus and then plus, and so on. Okay, how many blanks am I going to want for this one? 5. 1, 2, 3, 4, 5. Very good. I already heard it. My numbers are 1, or coefficients are 1, 4, 6, 4, 1.
1, 4, 6, 4, 1.
Okay, so on this one, my A term, my first term is 2p. So I'm going to go 2p to the
First.
fourth, 2p to the
2p4, 2p3,
third,
2p2,
2p to the second,
2p1.
2p to the first, and 2p to the 0, which we don't write. Now, if you have a negative, you got to pay attention to that one. So we have a negative q. So we're going to have negative q to the
4,
fourth, negative q to the
third,
third,
negative 2 to the second,
bless you, negative q to the second,
negative 2 to the
negative q to the
first,
first, and negative q to the 0, which we do not write. So on this one, you need to pay attention between negatives and positives plus distributing. Okay, so what is 2 to the fourth power? Very good, 16. So that means we're going to have 16 p to the fourth. Okay, I'm not going to write plus or minus right now. So we have to think about it. And I kind of usually will like look at this and be like, okay, a negative to the first power is only one negative, therefore it is negative. So this is going to be a minus instead of a plus. So I take care of negative, positive, and then I'll go back to the numbers, okay? So I have 4 times, and then 2 to the third is 8. And then I still also have p to the third. What's 8 times 4?
32.
So we have 32, p to the third, q to the first, or just q.
Oh, it's 4 times.
And then it's a positive.
32.
Good. So then negative to the second power is going to be a positive. So this time I'm going to write a
Positive.
positive.
There's going to be 4.
24.
4 times 6 is 24.
Okay, and then 2 to the second is 4, and then we have p to the second and q to the second. So what number is going to go down here? 24. P to the second, q to the second. Good job. Okay, and remember I said there's a pattern. So it's going positive, negative, positive,
Negative.
negative. And a negative to a third power is a negative. 2 negatives make a positive, but you have a third one, so it's going to be negative. Okay? 2 to the first power is just 2. So we have 4 times 2, which is 8. And then p to the first is just
P1.
p. And then we have q to the
Q3.
third. And if this is negative, then this one's going to be
Positive.
positive.
Wait, so it's always opposite?
Goes back and forth.
Positive to the 4.
So it's negative, positive, negative, positive, negative. Oh, wait, yeah.
So odd exponents give us negative, even give us positive, and so on.
Oh,
All right. How many blanks do I have on this one?
well, that's going to be 4.
4. Good job. 1, 2, 3, 4.
And it's going to be a pattern. Plus, minus, plus, minus.
Very good.
Very
To start off, I'm just putting the pluses, but then when we move down, when we're actually simplifying it, it'll go to the plus, minus, and so on. Very good. My numbers in front are 1, 3, 3, 1. And what are those numbers actually called?
Exponents.
Coefficients. Okay? The number in front is a coefficient. My coefficients ends up changing when I simplify the problem, but that's what we need to start with is those numbers. Okay, so then, what's going to go in my first blank?
Well, that's going to be
5 to the third, and then we go 5 to the second, and then we have 5 to the first and 5 to the 0, which we don't write.
1,
With my second term, what am I going to write?
Y,
Not y. Negative y to the third, negative y to the second, negative y to the first, and then I'm not writing one. Okay, what is 5 to the third power? 125. Plus, this next one, we have 3 times and 5 to the second power. Oh, I wrote plus and I should not have done that.
good job.
It's a minus. Why is it a minus?
Because of there's only one.
Very good. Negative to the first power is a negative. You should always do that first, and I did not. Okay. What's 5 to the second power? Nope. 25. Good. And 3 times, very good, 75.
And then that's going to be Y.
And then it's just going to be y to the first, which is y.
Y, yeah.
Okay, next term. Good. It's going to be adding because a negative to the second power is a positive, and we already know that this went negative, so this next one's going to be positive. And then we have 3 times, which is 15, and it'll be y to the, and since this is plus, the next one's going to be minus, and it's going to be y to the third. Can I get a thumbs up or thumbs down right now on your understanding? Okay, good. Those of you that are not quite sure about, is there something that I can kind of explain better or something that you're confused about, or is it just...
It's just the whole, like the only one that's different is like, you know, when 1, 3, 3.
And see, when it's
So, see how this is a 3 exponent? Go to the row on the Pascal's triangle that has a 3. And those are the numbers that go in front. See how there's 4 numbers here, and we know that we need 4 blanks? We write those numbers in front of each of them. So you're using Pascal's triangle to get those numbers. Okay? So that means on this next one, how many blanks am I going to have? Very good, 6. Are some of you already doing this?
Wait, hold on. 1, 2,
Okay.
3, 4, 5, 6.
So those of you that were a little bit confused, if we go to our 5th row here, right? The numbers that I'm going to write for the 5th row, for the 5th exponent, is 1, 5, 10, 10, 5, 1. Because those are the numbers that are after the 5 here. Like my 1, 5, 10, 10, 5, 1. Okay, so now what am I going to write next?
2x squared to the 5th.
Very good. 2x squared to the 5th. Now this time I have an x squared here, so you got to be careful with that. What do you do with powers to powers?
Multiply.
You end up multiplying them. Okay? So then we're going to 2x squared to the 4th, 2x squared to the 3rd, 2x squared to the 2nd, 2x squared to the 1st, and then very good. You've been listening. Okay, so then our second term is 5. So we're going to start here, and we have 5 to the 5th, 5 to the 4th, 5 to the 3rd, 5 to the 2nd, 5 to the 1st, and 5 to the 0, which we do not write.
Can you please explain your shirt? And then we don't get it.
Does anybody understand my shirt? It's important stuff. What is the square root of -1?
What?
We learned about it. It's something imaginary.
Imaginary
I.
shit. Oh.
I. What's 2 to the 3rd?
8.
8. I
A lot.
8.
A lot.
Does anybody know what the symbol is?
I can't even think.
We haven't talked about it.
Exponent.
Sum. This means sum. When you're adding everything up. I ate some pie, and it was delicious. Okay. Amazon. Okay.
Hey, somebody's here.
So do you,
We'll figure it out. Okay. But we'll have to do it on Monday. Okay. All right. So last one here. Okay. Are you guys good? You can come in and hang out. It's fine. All right. So as we go through here, 2 to the 5th power is what? You guys should know this one. We do it all the time.
32.
32. So we have 32, and then powers to powers we multiply, so we get x to the 10th. Okay, so I'm just going to bring that back down. 32x to the 10th. Okay, on this next one I have a 5. That's in front. 2 to the 4th power is what? 16. And then I still have another 5 at the end, because the 5 to the 1st. So 5 times 16 times 5
7.
is 400. And then in terms of your letters, let's go back and look at our letters. I have x squared to the 4th, and 2 times 4 is 8. So this is x to the 8th.
Oh, right.
because you just multiply the exponential.
Yes. Powers to powers, you're
I
multiplying.
was thinking.
Okay, so next, in terms of our numbers, I have a 10 times. This 2 is to the 3rd power, 2 to the 3rd is 8. And then I have a 5 to the 2nd, which is, and 10 times 8 times 25 is 2,000. And what is my x going to be? X to the, very good. Plus, next one, I have a 10. 2 to the 2nd is 4. And then 5 to the 3rd, very good. And when I multiply those together, I get
5 million.
5,000. And it's x to the 4th. Do you guys notice a pattern there?
No. 8. Oh, it's going down by 2. So
4.
then it's going to be
Where, like this is a second exponent and it's going down by 2 each time.
X.
Kind of interesting. All right, plus. Okay, I get 5, and then 2 to the 1st is 2. What is 5 to the 4th?
8,000.
5 to the 4th is not 8,000. 5 to the 4th is,
100.
very good, 625 is correct. And 5 times 2 is 10, and 10 times 6, 25 is,
6,250.
that is it, very good. And it's going to be x to what power?
Two.
To the 2. Because 2 times 1 is 2, and then we also know it's going down by 2.
Oh, I know that.
And 5 to the 5th. Anybody know 5 to the 5th? Gentlemen, 5 to the 5th?
3125.
That's right. Good job, calculator. All right, 3,125. There's your answer. We are done.